we are going to see the next topic, that is transform coding. So, to say in outline about transform coding, normally in earlier coding we are supposed to see about Huffman coding or fundamental coding theorems. So the coding theorem will be directly applied. The coding theorems will be directly applied on the original image. That is, the image will be in the time domain or spatial domain. The image will be in the time domain or spatial domain. In that directly they will be applying the coding algorithms. So this is the scenario of earlier coding algorithms. So regarding this transform coding algorithm, what is the changes we have carried out? That is, the image which is in the spatial domain, is transformed using some transformation function to frequency domain. It is transformed to the frequency domain, and then some suitable coding algorithm, some efficient coding algorithm is applied to reduce the data size. So this way of coding, we can say it as transform coding. So what is the scenario here? Image will be normally in spatial domain, which will be transformed to frequency domain, and then the corresponding analysis scanning will be carrying out. The complete pixels are scanned, it is analyzed, and then the coding algorithm is some suitable coding algorithm is selected, and the data size of the image is reduced. So this process of coding, we can say it is transform coding. So now we can see in detail about the theory of, in this coding we consider compression technique that are based on modifying the transform of an image. So here we will select the technique. After transformation of the image, we will see that how is the image. According to that, we will select one compression technique. Some compression codec we will be. In transform coding, a reversible or linear transform, such as Fourier transform, that is used to map the image in a set of transform coefficients, which are then quantized and coded. So what we are doing, we can use some transforms. So generally, what are the transforms we are having for an image? That is Fourier transform. Very popularly we will be using Fourier transform, discrete cosine transform, Walsh transform, wavelet transform, Hadamard transform. So like this, a series of transforms are there. There is a series of transforms are there to transform from spatial domain to frequency domain. So this transforms will be helpful. These transforms will be helpful to transform from time domain, spatial domain to time frequency. So when the image is converted to frequency domain, it will be helpful for the in-depth analysis of the image. Complete analysis of the image can be easily carried out. So it will be suitable to carry out some efficient coding. So next point, when we are seeing the most natural images, significant number of coefficients have small magnitude, coarsely quantized with L. So once the image is transformed to frequency domain, then we can apply some quantization. So quantization will reduce the data size, it will trunk off and it will round off, and it will reduce size. So these are helpful. So when we are seeing about the block diagram of an transform coding, the input image will be there. So for a efficient computation, it will be splitted into various sub images. It is splitted into various sub images. Example, a 32 cross 30 image is splitted into a 4 cross 4 small sub images. Then forward transformation is applied. The transformation can be either DCT or DFT or DWT or whatever be the transformation. The transformation can be applied. Then after applying the transformation to reduce the size of the value, we will use some quantization, that is truncation or rounding off. After carrying out truncation or rounding off, so it will be subjected to accommodate in particular length of data. Then simple some encoder will be applied, some coding algorithm. Like earlier what you have studied, Huffman coding, Shannon-Fanon coding, or Shannon-Fanon coding, or bit length coding, or and some coding algorithms they will be applying on in that. Then the image will be, the compressed image will be obtained. Then the compressed image will be obtained. So this compressed image then can be subjected to storing, or it can be subjected to transmission to in the communication. It can be the communication. So after receiving this, the corresponding what are the forward processes we have carried out, the corresponding inverse process we will be carrying out to reconstruct the image, to recover the image. So in this way, first we will carry out, say here we are carried out encoder, he will be carrying out decoding. Then there we have carried out forward transformation, here we will be having a inward transformation. So after that, all the splitted sub images are again constructed back, again combined back, and such a way the image is decompressed again. So again it is brought back to a normal image and it is used. So this process of using both the transformation and coding, and we can say is as transform coding. This we can say it as transform coding. So these things were very detailed as theoretically we have actually explained here below. So this way of transform coding is currently being used in almost all practical applications. We are currently being used in such a way, that is, we are after applying up transformation only we are supposed to prefer some coding algorithms. This is being followed in both images as well as in videos. In videos also we are following the same thing. Okay, so next we can see another algorithm. Thank you.